A solution of glucose boils at 100.52 degrees Celsius at the atmospheric pressure. If Kf and Kb value for water are 1.86 and 0.52 Kelvin kilogram per mole respectively, then the same solution will freeze at. It means you have the boiling point of this glucose solution, that is 100.52 degrees Celsius, and now you just want to find out its freezing point. Simply, we should know that there is a relation between Kb and Kf value. What is that relation? You should remember here that this delta Tb upon delta Tf is equal to Kb upon Kf. This is the relation we should follow. We know the simple formula that this delta Tb is equals to Kbm, while this delta Tf is equals to Kfm. On the basis of this, we have this formula. Now, let's place the values here. If we talk about this delta Tb, this is the change in the boiling point when it was water. It means pure solvent was there. The boiling point is 100 degrees Celsius. And as you add glucose to it, its boiling point becomes 100.52 degrees Celsius. So, what is the change in this temperature? That delta Tb value, you can find it out. That is 0.52. Because this delta Tb is equal to 100.52 minus 100 degrees Celsius, that is the boiling point of water, and it would be 0.52. This is the delta Tb value. Now, delta Tf you just want to find out. You have the Kb value and the Kf value both. Where is the Kb value? That Kb value is given 1.86. That's why I'm just writing here. This is 1.86. And it should be divided by the Kb value, that is 0.52. That is equal to the Kb value. That Kb value is clearly given here. That is 0.52. Would be divided by the Kf value. Where this Kf value given? This Kf value and Kb value are given here. This is 1.86 for Kf and 0.52 for Kb value. So I'm just placing here the values 1.86. It means these two terms would be cancelled out and this delta Tf would be equal to 1.86. This Tf you have. Now what would be the value of the freezing point? And we know that this delta Tf value is equal to Tf dash, that is the freezing point of pure solvent, that's water, minus the freezing point of the solution. And in this case, delta Tf value we already have, that is 1.86. That should be equal to 0 minus this Tf value. And what would be the Tf value here? It would be minus 1.86. This would be the value that to be used here. So it means that we have our answer in this case, and that's why we can clearly choose here the correct option. Where it's given in option 3, and that's why this is my correct answer. Now, after this, it is the turn for the next question. Question number 77. For a zero order reaction, the slope of plot AT versus T. AT is the concentration at time T versus T we have to plot here. We know that for a zero order reaction, if we're talking about for a particular zero order reaction, AT is equals to the initial concentration minus KT. This is the formula that we use. And if we plot the graph between these two values, the graph that I'm just going to draw here, this is the graph between the concentration at T time with respect to time. I'm plotting here, and it's a straight line in this way. This is the line that you will obtain. Now let's compare the equation of zero order with the equation of the straight line, that is y is equals to mx plus c. So in this case, we just want to know what is the slope. The m value we just want to know here. C is the intercept value, that is a naught. It means this a naught value is here. This value is a naught. Now, this m will represent minus k. This is representing minus k, At the x-axis you have t and at the y-axis you have AT. That is why the slope is representing minus k value. And if it is so, we can easily choose the correct option. That's option 3. Now, after this, let's take question number 78. The enzyme which converts starch into maltose. Basically, this is the biochemical reaction. The starch is there, it is getting changed into maltose, another sugar, the simpler one. And in this case, the enzyme that we use is diastase. So what's the enzyme? That is diastase. And that's why this is the correct answer also. Answer is again option 3. Let's choose next question. Question number 79. The osmotic pressure of an aqueous solution containing 3.42 gram of sucrose. So the mass that's given here is 3.42 gram of sucrose along with its chemical formula it's given. Now, in 250 ml solution at 27 degrees Celsius we have to just find out the osmotic pressure, that is pi, and this pi is equals to CRT. In this case, we have to just find out the C value. R value is already fixed and temperature is also given. Let's place the values here. The concentration you can find out with the help of the given mass, that is 3.42 divided by the molar mass of the sucrose. Molar mass of the sucrose is 342 gram per mole. With the help of its formula, you can even calculate. So this is divided by 342. These are the moles, and let's divide it by the volume of the solution. That's also given. It is 250 ml. And that's why I'm just dividing it by 250, and it should be in liter, that's why. This would be the value of concentration, then the value of R. And in this case, we have to take the value of R in liter atmosphere per Kelvin per mole. So that value is 0.0821. Then the T value is also given, that is 27 degrees Celsius. What does it mean? It is 300 Kelvin. If you solve this, you will find out that the answer would be 0.98 atmosphere. This is your pi value. And let's check the option. That's option 1 in which this answer is given. And that's why I'm choosing it as the correct answer. Now, after this, let's take the next question. Question number 80. Which property of the colloidal solution is independent of the charge present on the colloidal particles? In this case, we have to just consider the given properties. One is the coagulation. Coagulation of the colloidal sol or the colloid simply is done with the help of the charge. Similarly, we talk about the electrophoresis, that is also the movement of the charged particle in the presence of the electric field. Even if we talk about the electrodialysis, that also occurs with the help of the charges. And that is why these three are charge dependent properties. But if we talk about the colloidal property, if we talk about the optical properties like scattering of light, that's the Tyndall effect, that is independent of charge. And if it is so, this optical property would be considered as the charge independent property, and that's why option 4 is the correct option for this question. And yes, it's a turn for next question, that is question number 81.